Please join me in applauding him. Yeah.
Okay, so let's talk about modern software engineering in practice. So Comic Sans MS is the modern software engineering font. So before I start diving into it, I'm going to spend a second to talk a bit about myself. So I worked for 2 years at a pretty big company. There were like 10,000 employees, offices worldwide, and I realized I didn't like it all that much, and I started getting feedback. I switched to a smaller company where I've been working for the last year. And I put startup in quotation marks because I don't know what that word means. So if you know, talk to me about it. And in the startup, we're about 30 employees. I'm on a team of five developers, including me. And we basically build a website that companies host on-premise. So we just give it to them, and then they only call us when there's problems. Yeah, and I'm also like a full-stack developer. We do a lot of stuff because we're a small company, so we do stuff like support, DevOps, any buzzword that you've heard, we probably do that. So let's talk about modern systems. And before I do that and talk about the practical ways that these systems are, I want to establish what it even means to be, what a system is composed of, right? So we'll start at the beginning, obviously, hello world. And the first sort of like basic programs that we start with are stuff like this, factorial. And then right at the beginning, the problem that we face is like, well, how do we make bigger programs? And for some of you, hopefully have seen this book. There's a book called Design Patterns, and they just throw the book at you. And the design pattern is basically a way to solve a problem in software, a reusable way. And so there's 4 people were working in the industry for a while. They saw that they were solving the same problems over and over again, and they wrote a book about it. And so now instead of like struggling to figure out your own solution, they have these definitions for what these problems are and how you can solve them and sort of the pros and cons of the thing. And so it helped reason about software at a more abstract level. And so now when we see something like this, we know that this is a singleton. If you didn't know this is a singleton, this is a singleton. And so now we can call it a singleton. And it's cool because no matter what programming language that you're in, you know that this is a singleton. So layers of abstraction, it's good, right? So the other thing is that, like I mentioned, systems are built up of these design patterns that all work together. And the abstractions are everywhere. In the libraries that you use, maybe you have some like implicit patterns within your code base, but they're there. And so that's the first step of the first composition block of what a modern project is. And so very rarely are systems worked on by one person. So how do we get people to work with each other? And source control, right? So source control lets you track changes to your code base. So every commit or like every change of code is tracked so that you can revisit it and understand why you did that. And so like with a commit message, you can say like, now it says hello Bob instead of hello world. And then the next person who comes along can understand why that change was introduced. Another thing that we can do with source control is manage different application versions. So if you release Windows 7, do you stop, like, there's also Windows 8 and Windows 10, and with source control, you can maybe like work with branches, if you've heard of those, to manage that. So now that you've got your design patterns and your source control, you can work with other people, and then very quickly you run into another problem, which is how do you like run your code in that if you're working with Eclipse, I saw a lot of hands earlier for the Java thing, so I hope you guys are a bit familiar with this. But when you build this thing, you usually have to go into this menu and like configure some things, and someone else who's trying to run your project doesn't know exactly how to do that. So like the question is like, what does this green button do? So like, how does that work? And if you press the green button on one machine and then you press it on another machine, like what is the difference? It should behave the same way. So the answer to this problem is build tools. So build tools are recipes for creating artifacts. And here I'll just hand wave and say that an artifact is like the thing that you're producing. So an executable in Java, jar, war, in Ruby, gem, whatever. And your build tool provides a reliable way, given an input source, to produce the thing that you need to produce. And so in the Java world, there's like Ant, Maven, and Gradle. Those are pretty popular. I have a Gradle sticker, but I don't know if you can see it. So the next thing that we want to get to is now the build tool can report compilation errors in a way that like it's the same for everybody. So you've expanded your project to multiple people, and you know that there's a compilation error, but you want to get like, as soon as there's a compilation error, you want to know about it so that you can do something about it. And that's where continuous integration comes in. So continuous integration is sort of the way that you check out the code every time there's a new commit. You do the build, you make sure that it didn't break anything, and now you get the feedback right away. So if you break the code and you're on a team of like 15 developers, you're not blocking anybody. You've got an email message saying, please fix it. You can fix it right away. And the place where this sort of continuous integration setup here really helps shine is when you also bring in testing. So we talk a lot about testing and unit testing, so I'll sort of introduce what that means for those who don't know, but the idea of unit testing is testing a really small part of your code, a unit. So for the example where we want to reverse a string, like you know ahead of time what your output should be. So if you wanted to reverse the string like stressed, which you know that that's desserts, which like can't be a coincidence, like it's almost too perfect. But you know ahead of time that it's desserts, so you can write a test that explicitly verifies the behavior of your code to, yeah. And there's a lot of different kinds of testing, and I'm not gonna like just enumerate the huge list on Wikipedia. They solve a lot of different problems, and it's good to know about the different kinds of things that you can do for your system because they come in useful in a lot of different scenarios. And I'll talk a bit about end-to-end testing. So if you're working like on a banking website and you want to test what the user will do, if the user logs in, transfers money from their checking to their savings account, you're not really talking about like what the code does, but you're still talking about verifying that the behavior is what you would expect it to be. So when you combine all these things with continuous integration, you know that every sort of change that you make, you cover the units, like small stuff like the stress desserts, but you also cover the big picture, which is what the user would experience. Then if you are like me and you sell software to companies that they host themselves, they're usually only talk to you when there's a problem, and it's something you're testing catch maybe. And so that's where the last piece of what a modern system, I'll say, is, which is logging. So the idea behind logging is that you write a statement for everything that you're doing, explaining what it is that you're doing. In the banking application example, the user logged in, he clicked on his checking account balance, he transferred, and this is what happened. And it's really a convenient way to retrace exactly what happened, if there's an error particularly, so you can go and look in the logs and find out what happened. So in this dummy example, like we'd have like a transaction ID, and we can search the logs to see what exactly went on. So these are the minimum pieces, I'll say, for a modern software engineering project. And there might be more or whatever, but this is my talk. And so what happens when we take all these different things that I've talked about to the very extreme, right? So we've got design patterns, source control, build tools, tests, logging, and the thing that binds everything together really is the continuous integration. So what do we do if we do this really crazy? And I'll state without proof that the future of software engineering is what you get, which is continuous delivery. So the elevator pitch for continuous delivery is that if you introduce a commit to a code base, continuous delivery is the idea that it can go through a series of tests, automated, all the different kinds of things you could do. You could deploy to different environments, and somebody can just like okay the build and say, okay, push this into production now. And I'm not saying like you just approve anything, but the idea is that the release process is really, really automated, and the more that you automate, the less you're likely to make mistakes, and the faster that you can iterate. So now that I've introduced and said what a modern project is, I want to talk about sort of problems that we can get into when we try to bring this to the real world. If your system is already doing continuous delivery, that's great, but like, what if it's not? And so that's what the second half of my talk is going to be about. So the killer question that I really hate hearing, but it's a really important one, but it's like, what's the business need for doing something? If you're working in a big company and they don't have testing and they don't have continuous integration, you sort of have to convince somebody that it's a good idea. And if they don't already have it, then there's probably a reason for that. Like, they don't see the value in there. And in terms of business need too, like if there's really horribly designed code where it's hundreds and hundreds of lines of copy-pasted code across multiple classes, hopefully all of you are thinking, let's fix that, let's find a better way to make that work. But you sort of like need to justify what you're doing. And if it's an area of the code that doesn't really change, is there a risk? Are we fixing a lot of bugs in that area? If the answer is no, then like if you're, where's the business need to fix it, right? It can't be like it'll help me sleep better. Another challenge is in like keeping a system healthy. Let's say you've done the hard part that I won't talk about, where you've convinced everybody that these are good ideas. You have to sort of change your system. Like you can't just snap your fingers and your testing is amazing. And depending on if you're a big or a small company, that has a different impact. If you're in a small company, you might not be able to afford to spend all the time building up your testing, building up some things, if it means the difference between like keeping your job or like having code be a little bit nicer, or tests that are a little bit more reliable. Another problem that you get into smaller companies more often than bigger companies, but if you don't have the expertise to do it, you all now really believe in continuous delivery because I told you to, but how do you do that? You can know that it's a good idea. You can have like really strong technical arguments for why you should do it, but you need to have somebody bring in the expertise and sort of drive that. And sometimes you'll run into roadblocks, and if you're in a small company, who do you talk to? In a similar vein, if you've got a system that's like locked into a particular technology, you're using some tools that suck, but you've been using them for forever, and this is really tied into the business need that I was talking earlier. Like, what's the business need for changing this? Because not only do you have to change the way that things are done, which is money, like time is money, but it's probably like making you less productive. But sometimes it's okay for that. Where's the business need? If you can convert a system to a much better system, like let's say a framework, even if you do that, even if everybody's going to be more productive, you're introducing risk, and you have to test these things. And if you don't have testing in place, the other thing that's all these things are all related, but and I've already mentioned this, but like a gross solution is still a solution. If the end user doesn't know like that you guys have horrible design in your code, it doesn't matter. Are they still able to use your product? And finally, I wanted to bring up Maslow's hammer, which you probably all know, but I just wanted the privilege of saying what it was. If everything you have is a hammer, then everything looks like a nail. So this is tied into like the vendor lock-in. Like if you only know a particular set of things, you're more likely to want to solve those problems in the way that you know. even though might not be the best way to solve those problems. So speaking of nails, another thing that might be a little bit tricky is working with people who are wrong. If the CTO or somebody at the company who's in charge of making these decisions is invested in sort of a thing that makes everybody unhappy, but they're the CTO, like, guess what you're going to be using and guess what you're going to be doing? Like, they call the shots. So in terms of company side stuff, this is stuff that you might have to deal with when you transition into being full-time software engineers. And so from a more individual perspective, like, what kinds of things can you do to be good in a company? And there's no slides, but I see them. So there's a lot of things you can do that can make to grow. There are a lot of things that you can do that will help. People will want to work with you. People will want you on their team because you know and you're excited about things. And one of the things that you can do is help less experienced programmers. So if you know people who are struggling and want help with something, it's a great way to learn and to learn how to teach, give a talk or whatever. If you help less experienced programmers, that makes you more attractive to companies and just cool in general. There's also like a certain skill of like knowing how to ask a question. So it's sort of very easy to just tell them like, oh, I don't know how this works, but you don't describe what kinds of steps that you've already taken. And in terms of like respect for somebody's time, you should probably make sure that you've easily established and well established what exactly is going on so that they want to help you in the future. Another thing to help grow is to read the manual. Oh, it was just me that was wrong. Okay. Yeah, so read the manual. Reading the manual is a really good idea. You can learn a lot from documentation, and it's a skill that will help you when you need to ask questions too. And so another similar sort of spirit of advice is to understand and care about how things work. If you want people to want you on their team, and if you want to be like a really a person that contributes to making and keeping systems really great, you should learn, if this is what you're interested in, you should care about how things work. You can tell when somebody is really excited and interested in something, and which sort of ties into very easily to try to be excellent to yourself, to others, etc. And if I find, sweet. Okay, so I had to put in an XKCD slide, but this slide really resonates with me here. Randall jokes that things that were useful to his career were things that it was most useful to spend one weekend messing with Perl than all of the classwork and all of the homework put together. And this really resonates with me, and it was something that I did this with Perl, I did this with Bash, I spent the weekend to learn Git, and it's paid off thousands of times in the career, and it's really great. I really recommend it. And so there's also another sort of caveat where like not everybody has the same level of enthusiasm for this sort of thing, which is okay, and it's not like everybody should be exactly like me, but talk to people who have similar interest levels as you so that you can sort of help each other grow. And another thing that's also really cool to do, if you're trying to figure out how to better yourself as a programmer in school right now, to read smart people's code. So if you're in the Java world, if you read the Guava library documentation and the source code, it's like a treat. I recommend it. And experiment outside of your comfort zone. I think that people should do this a lot. This is related to what I was talking about, where if you're like locked into a particular technology and you think it's the best, you're missing out on huge opportunities. And if you're a Java enterprise developer, and if you spend just like one weekend experimenting, playing around with Ruby on Rails, the things that you'll learn and take back to the workplace is like invaluable. It really changes the way that you look at things. So I'm guessing a couple of you are here to find jobs. The obvious thing to say is to find the right fit, but that doesn't really mean anything. So I'll sort of talk about my experience with it, the major differences that you probably already know about big and small companies, there's advantages and disadvantages, obviously, but like in a big company, you can get by without knowing how a lot of the stuff works, because you can be specialized to a particular area, which is a good and bad thing. If you want that, that's great, but if you want to touch on a lot of different things and you're interested in how a lot of this stuff works, might be harder to do it at a big company. I'm generalizing, obviously. And the other side to that coin is in a small company, you get to work on a lot more different things, but if you're stuck, like, that's it. And you don't know necessarily if the things that you're doing are the right way to do things, but you have to get them done because that's how it works. And also another really important thing is, if you're interested in learning a lot, or like the kinds of learning that you want to do, you probably want to pick something based on that. And my easy question for you guys is, if you're looking for a really good place to work, just try to find out if they do continuous delivery. And then, so I think there's like a lot of pressure in like software engineering, computer science, all that sort of stuff to make people do stuff they don't want to. Feel free not to do a bunch of things if you're not really interested. It's fine to not want to come to conferences, but you're probably the wrong audience for this. And so I wanted to also recap a bit and expand a bit more on this continuous delivery thing that I mentioned earlier. Continuous delivery is sort of a set of really good ideas that when combined, like, create the thing. So if you just happen to do a lot of things that are good ideas, like if you have environments where you deploy servers, how do you create those environments? Well, you have to write sort of scripts and configurations to create those machines. So you don't want to have like Snowflake servers. So Snowflake server is a server that is unique, and nobody knows how it got to that state. Nobody knows why it works there and it doesn't work somewhere else. And so one of the ideas behind continuous delivery is to put all of that in your source control so that you're always able to bring that machine back up if you need to. It's also a little bit related to scalability, where if you want to, if you have more servers that you need to bring up, like, how are you going to do that? It might not be a problem today, but if all of a sudden you're getting a ton of traffic and you need to spin up servers, you want to have that recipe there somewhere. And so a lot of the ideas with continuous delivery are about automating absolutely everything. I also have a lot of random references at the end of this for articles and sort of ways you can ramp up. And I'll also be around at the conference if you want to talk about anything. But that's pretty much it.